Welcome to another video in the Reigate Maths series on integration. This video focuses on integration by parts. This is a formula that you are given in the formula book. Notice in this video we are not going to derive the formula. You can do it yourself by using the product rule, but for now we're just going to look at using the formula. So what is the formula? Well, it looks like this. When is integration by parts used? When we are integrating a product of two functions. Typically, when integration by substitution doesn't work. So with all the substitution questions you've been doing, you've probably noticed there's some link. Maybe it's that there's two polynomial functions, one that differentiates nicely to the other, or something like that. In this case, this is very useful for when that doesn't work, or is unwieldy or unpleasant to do so. But do check, unless you are told to use by parts, check whether substitution works first, because it might do, but then again, it might not. So, the main thing with this is don't get confused between by parts formula, which you are given, and the product rule formula. Product rule is for differentiation, this is for integration, but it looks very similar. Where's the major difference? Well, it's here. Product rule, we identified the integral being u times v. Here, the derivative. Here, we are identifying the integral, the thing we're trying to integrate, known as the integrand, as u times dv by dx. The layout works almost identically, and the process works the same, but it's very, very different. So, let's have a look at an example. We're going to look at this first example. We are integrating x sine x. So the first thing you need to decide is which of our two functions is u and which one is dv by dx. And there's a very simple rule. If there is a ln anywhere in this integrand, there's a ln anywhere, that's u. If there is not a ln, the bit that's just x or x squared or the nice simple polynomial function. So in this case, x, that's the u. The more interesting function, shall we say, that's almost always the dv. Again, the only time where that is not the case is if there is a ln involved, and we'll look at those later on in this video. So knowing that, we're going to identify x as u and dv by dx as sine x. Now, so I don't get confused between my layout for this and the formula and things like that, between this formula and the product rule formula, I purposefully lay out my working slightly differently. Whereas with the product rule, I'll have u and then v. With this, I have u and dv by dx on the top, because those are the things I'm getting from the question. I now need, for my formula, for the right-hand side of my formula, I need du by dx. So that's 1 in this case. And I also need v. How do I get v? I've got dv by dx. I need to integrate to get v. And this is where, again, it differs from the product rule and the quotient rule. You need to integrate dv to get v, whereas with the other two rules, you differentiate v to get dv. So do make sure, do be careful when doing these questions that you're going the right way and doing the right operation. Because once you've got this, it's just a case of using the formula. So therefore, the integral of sine x is going to be u times v minus the integral of v times du. And don't forget the dx on the end. Let's tidy this up before we worry about integrating this bit. Minus x cos x, there, just multiplying there. Now notice how we've got minus and a minus. We could, of course, integrate minus cos x. That's fine to do that. But why would we want to? Why would we want to worry about having two minuses next to each other later on where we can see very clearly it's going to simplify there? This is almost the expectation that you must simplify this step. The reason being, typically, it's going to make integrating this far easier. And we can see cos integrates to sine. Now, of course, you could tidy this up if you wanted to. If you didn't like having minuses on the front of your function, perhaps, you could, of course, do that. But you don't need to. This is it. So this by parts method is, on face value, very straightforward. It's just find these things, put into the formula. But do be wary. There's lots of scope for you to make error. Also, sometimes you're going to have to do by parts multiple times. Here's our second example. X squared e to the 2x. Again, identifying u and dv. We don't have any luns, so that means u is the x function. The bit that's just x's or x squareds or that kind of thing. And the dv is the other function, whatever it is. Here, we differentiate and integrate. Be careful when you're integrating. This is typically where students make an error. Because, again, this is very similar to the product rule and quotient rule, students will quite often go, oh, it's differentiation. So differentiate this and get not this answer. The downside with this type of question in the exam, if you do that, you're probably going to lose the rest of the marks from here. Maybe you'll get 2 out of 6 if you're lucky. But knowing to do this and for using your incorrect answer. But be careful. That is a very small mistake to lose 4 marks. So, once we've got that, let's have a look at using the formula. So again, we've got u times v. So I'm just going to tidy this up as we go now. Minus the integral of v du. So 2x times a half e to the 2x. Simplifying, we get that. So with the previous example, here we just integrated. What's the problem with this one? We've got a product again, which means only one thing. We're going to have to do by parts again on this little bit. So whether you do that separately as its own thing and then plug it back in afterwards, or just kind of do it as you go here, that's fine. But the layout is important. So what I would do is start again. Now, it's potentially poor form to use u and v again, but you're not going to lose marks for that. If you're particularly worried, just pick other letters. Use maybe P and Q if you wanted to. So, this is where, depending on the way you want to do your working, you may differ from what I'm going to write down. So you may want to just work out this bit here on its own. That's fine. And then put it in at the end. I'm not going to do that. I'm going to do it all as one and keep going with this method. Now notice as well, I could have had u equal 2x and dv by dx equals a half e to the 2x, but that's going to overcomplicate this bit. Simplifying here is going to save so much hassle later on. So I would strongly advise you check to see what happens with that. Now this is where I'm saying be careful with your working. Don't just put an equal sign and keep going. You need to refer back to this, because this is the thing you're calculating. So we've got a half x squared e to the 2x minus. And then remember to put in a bracket. uv minus the integral of v du. Now notice how I haven't put a plus c yet. Typically when I'm doing integration by parts, I'll just stick that in at the end. So we've got a half x squared e to the 2x minus a half x e to the 2x plus, and then we integrate this bit, a quarter e to the 2x plus c. And this is now done. So notice what determined that we had to do integration by parts twice. The fact that this is squared. So watch out for that. You can see, oh, I've got x squared times something else. Chances are I'm going to have to do by parts twice. Not always, but the majority of the time, if this is x squared, you're going to do by parts twice. Now what do we do if we've got limits on the integral sign? So depending on what your textbook does, I find it's very unhelpful. It'll do something like, if we had this example here, it would do something along the lines of equals, oh, it's this bit between a and b minus the integral between a and b of x e to the 2x, and it all gets a little bit messy. This is fine to do, and if you can keep track of it while you're going, great, do that. But what I like to do is do all of this, not worry about the limits at all, and then say, okay, I've done the integration. Therefore, the integral between a and b of x squared e to the 2x is equal to this thing I have worked out evaluated at a and b, or between a and b. I find for me personally, it just helps me keep track of what's going on. I find if I start trying to play around with putting numbers in during this working, I get lost. And I'm inevitably going to forget a number going in somewhere, or I'm going to get something wrong. So that's definitely something to watch out for, but try both ways. You do whichever one works for you, because both are valid. Here's our next example. X ln x. So this is a ln. So we've already said that the ln has to be the u bit. But why? Why does that have to work? Why does it have to be u as ln x and dv as x? Well, what's going to happen if we do it the other way around? We get u equals x, so du by dx is 1. Nice. What's the integral of ln x? Not sure. It's not easy to work out. It's not a standard thing that you can just remember. So that's why we need to do it the other way around. So in this case, u is going to be ln x, and dv is x. It doesn't change a lot. We still do the same thing. Differentiate ln x. Integrate x. Then use the formula. v du minus, uv minus v du. Notice how here we have a nice simplification. So we get a half x squared ln x minus a quarter x squared plus c. This is much, much easier than trying to figure out the integral of ln x. So let's now try and figure out the integral of ln x, because this may well be something you're required to do in the exam. The thing with this is you have to know that you must do this by parts. Now, because we're doing by parts, u is definitely ln x, because there's a ln. We've said that that's the rule. If there's a ln, then it has to be u. But what's our dv? What function are we doing a product of here? There isn't one. dv by dx is 1. This is the same as 1 times ln x. And this is the way you must think about this integral in order to work it out. Once you've got that step, though, the rest of it, exactly the same. Oops. So the integral is uv minus the integral of v du. Now I know that this cancels to 1, but you need to show use of the formula. Don't skip steps here. So what we tend to get asked is, well, if we learn this, can we use it up here? I mean, yes, you could, but you need to prove it. In order to use this result here, to have these the other way round, you'd need to do this entire method first. So why bother? Why do this and then do this? Just do this from the start. It's much quicker. And that's integration by parts. Again, with these two examples, if we had limits on the integral sign, I'd do all this, then stick the limits in at the end. But that's my personal preference. These two, and anything involving a ln, are specific. You've got to do it this way. If it's x and then a function, you do it the other way. If it's two weird functions multiplied together, maybe you've got something like cos x and sine 2x, maybe it's not by parts. Maybe think about rearranging, multiplying, and trying to do substitution, or one of the other methods we've looked at. This is not foolproof. You might have to play around with the function first, because you might not want to use by parts. Thanks for watching.